Okay. So what is meant by a contour integral? It is the integration of the function of the complex variable in the complex plane which is carried over a particular contour. The integration has to be carried over a contour. It is like you are traveling. Suppose if you want to travel from Pondicherry to Chennai, you have to travel via some route somewhere. If not that road, you have to go by that road. I will not give any road. You go means how will you go? You have to go somewhere, right? Air travel also okay, but there is a way there. Air travel. There is a way, there is a path. That path has to be given to you. If I tell that I will not give any path, you should not also travel any path. Go means how will you go? That's the meaning. This integration has to be carried out over a particular path. You travel along a given path. And then if you travel like that, what is the value of the integral? Is the question. This particular point is clear. C means contour. Contour means just a curve only. If I say RE of Z here and IM of Z here, it's called contour. That's all. If you simply say like this, for example, if I say like this is your X, let me write down, this is your X and that's your Y, and you draw a parabola, for example, simple parabola like that, then you say that this is curve. So curve becomes contour, that's all. It's only a renaming. There is nothing to worry about that. So now the question is that how to perform the calculation. So the calculation of this integration is going to be simple if you understand the real variable integration. So real variable integration, you have to be clear first of all. Then you can come back and then do the complex variable integration. We are going to discuss a little bit about the real variable integration in two functions. Let me again come back here. You see here these two comparison. Comparison, what do you understand is f of x comma y is equivalent to f of z. Somewhat. They are not exactly same, but it's equivalent. So therefore, what happens is, if you understand how to perform the integration of f of x comma y, you also understand how to perform this. What is the difference between this one and that one is, here there is something extra available. Here that extra thing is not available. But this extra thing will not disturb you because this 2 into xy is just like x square plus y square. X square plus y square is one function of xy. 2 into xy is another function of xy. In what way it is different? It is just another function. That means I have to repeat the integration 2 times. One for this, one for this. Is the point clear? You perform the integration for this and keep the answer separately. You perform the integration for this and keep the answer separately. Put the I between there and keep the addition. So the purpose of the I has nothing to do. You have to keep the I and keep the answer there. So 2 times you have to repeat the integration, for one for that real part, one for imaginary part, and then plus put the I and then say that is the answer. So which means that your understanding is that you can do this one correctly only if you know how to do this integration correctly. Okay, therefore what I will do is I will give a small introduction about how will you perform the integration of the function of real variable. Okay, that's what I am going to do. So that will take only 5 minutes. You can easily understand what is. So here I am write down. Okay, so g of x comma y would be one function of 2 variables that we have. There can be any number of functions. This is one example. This is one requirement. Second requirement is curve. That is, we need a curve here. We need a curve. If curve is not given to you, you cannot do the integration. Therefore, this is the first thing. This is let. Okay, let means, what is the meaning of let? Let means permit me to accept that g will represent a function of 2 variables. That is one thing that we are letting, and not only that, we are also saying that, and let c is a curve which is given. Let me write down first what is this, then we will explain what is the meaning. Comma y of t. Let c is this, the parametric representation of the curve. So now only you have to understand. First you write down this, then let me explain. C is a curve, that's all. Any curve, straight line is okay, circle is okay, parabola is okay, ellipse is okay. You draw anything, everything is a curve. A curve can be described by different ways. One way of describing is called the parametric representation. There are 2 variables are there. Where are the 2 variables? X is one variable, y is another variable. 2 variables doing the calculation, okay, you can do, but it looks like if you can convert it into one parameter, it is good. Okay, I don't want x separately, I don't want y separately. You convert everything in terms of some t here. Then what happens? This is also t, that is also t, some function of t only. So instead of dealing with one function with x and another with y, I can deal everything with t only. So parametric representation will helps you to convert two variables into one parameter. Is the point clear? Two variable is there. Two variable will disappear. Only one parameter will come. As an example, you take what is the equation of the circle. Equation of the circle is x square plus y square equal to 1. This is an example of circle. But this is this the only way that you can write? That's the question. No, this is not the only way. You can write by another way also. How can you write? Or, okay. So that means x square plus y square becomes, isn't it? So x square plus y, a square cos square t plus a square sin square t becomes, you get back that. So now the question is, I have a circle. Circle is called curve. Curve is called contour. Okay, that is clear. Now the question is this. Do you want to write down the equation of the circle in this way? Do you want to write that? Or do you want to write down the equation of the circle in this way? Okay, so these are the two methods. So this is either 1 or 2. Okay, this is either 1 or 2. They are equivalent representation. So the second equation is called the parametric representation of the first equation. In a way, it is somewhat comfortable because two variables are disappeared, only one parameter is coming to picture. So mathematics looks somewhat simple. This is the reason. Okay, so you understand what is the meaning of this. Now how will you read this? The contour C is given by is the column there. So the contour C is given by parametric equations there. That's how you have to read. What is the equation? Here you have to delete this x of t and put the a cos t here and a sin t here. The point is clear. So this is the parametric representation. This is one way. This is way. Okay. So now, in case if you are going to consider that the function is g of x comma y, and you also are in a position where the contour is available in this particular format, then what do you want to do? Okay, these are there. What do you want to do? I want to perform this integration. If this idea is clear, so now we are talking about the real variable theory here. This one. Now, since we are going to talk about real variable theory, this is x here. So this is one option. How much to evaluate? How to evaluate? And similarly, you can also consider integral over c g of x comma y dy is how much? Okay, and then let me erase this. Okay, then how to evaluate this one, that one, and the third one? Let me write down here. Third one. So this is the aim. So first of all, aim should be clear. Okay, what is that we want to do? We are interested to evaluate this integral. But before that, we would like to understand what is g. G is a function of real variable. And not only that, the contour is now available in the form of parametric representation. Okay, if the contour is not available in parametric representation, you have to think how to do. Right now, it is available in parametric representation. Then how to do? That is what we are going to discuss. So this question is related for the condition that contour is available in the parametric representation. There is a clarity should be there. Then you understand what is x. X is this x-axis, y is y-axis. The question is what is s there. X is clear, y is clear. What is s? S is already some terminology is there already in mathematics. S tells you the distance here. Suppose if I am going to travel like this from here to here. Okay, let me write down s. S is the distance. It is a distance from A to B along the curve. Along the curve is important, not the line joining. Okay, if I am traveling like that, then you tell me how many kilometers I traveled. That is the S. Usually in mathematics, what is the name given to that? Instead of telling S, you say what is ds. You know it. What is ds? Ds is it is arc length because a small distance. This is one arc. Okay, because it is turning now, slowly it may turn like that. So if you take a small bit, it looks like arc. So the arc length is known as the ds, then the total distance is ds. So therefore, the meaning of this this is different, that is different, this is different. Here you have to evaluate so that ds is coming to picture. Here dx should come, here dy should come. They are not same. Why it is not same? This is, you can see from the graph. You see this? Okay, why it is not same? Let's see. You let us consider a small bit here. That's a small bit. Now what you do is you draw like this. You draw a horizontal line. What is this distance? Clear. And similarly come here and come here. So this distance is so dx is there, dy is there. Then where is ds? ds is this. ds is this bit. All the three are different. So since all the three are different, the value of the integral is also different. Okay, so therefore the integral along dx is different. Along dx means every bit. See, this is one bit. See, this is one bit, you put a projection. This is another bit, you put the projection. Similarly, this side you have to put the projection. If it is ds means no need of any projection, take the arc length and go. So therefore, three possible values of integrals are available. You must know how to evaluate all the three. If you know how to evaluate that, you can do the complex integration. The complex integration is nothing but repeating that many times. Same thing you repeat 2-3 times or 4 times, that's all. Then you get the answer here. So that is the idea. So now idea is clear. Now now the question is that how do I calculate ds? Calculation of ds is also already known to you. So I'll write down the formula for the arc length. So I'll write here. So arc length is given by, let me write down, ds is equal to, if you don't have the parametric representation, this formula you cannot write, you have to modify. Okay, so if the contour is available in the parametric representation like this, then this distance is given by dx by dt whole square plus take a square root here. This is quite familiar. First year BSc you might have studied. Okay. So therefore, we are going to substitute all these things there. Okay, let us now come back to the evaluation of the integral. So I will erase this portion. Then let us see how to evaluate. We are going to evaluate three integrals. Okay, three integrals are very easy. So I am going to write down only one step. Okay, in that let us write down the step for equation number 3, because that is the one containing ds here. That ds is written there. Okay, so therefore I will write down that equation 3 is like this: integral over c g of x comma y ds is equal to. So now what you have to do, you have to only replace. Yeah, come. What is x now? X is disappeared. What has come? X of t has come. Okay, x will disappear, x of t will come. Therefore, this is gone, and now I am getting x of t. Both are not same. X of t means a into cos t. X means x only. So they are not same. So x is gone. Now similarly, y also disappeared. You are getting y of t. So therefore, you write down comma. Here you write down y of t. So up to this over, then what about ds? What is ds? It is there. So you substitute that. Okay. So therefore I will substitute. So into, I will not put square root, I will put to the power 1 by 2. So therefore I can write down, this is dx by dt whole square plus dy by dt. So how to evaluate means, like this is the way to evaluate. So question should be clear and answer should be clear. What is the question? How to evaluate? Answer is here. You now substitute everything here, and now it is very simple. In how it is simple? You see how it is simple. G is a function of two variable. Now what happens? G becomes a function of t only. This is a function of t only. So the whole thing becomes dt. No, dt you can replace that. That is not a problem. Otherwise, no, you have to write ds by dt. This dt you can bring here and write ds by dt. So this idea is clear. So therefore, evaluation of 3 is very easy. If 3 is easy, what about 1 and 2? 1 and 2 are much more easier because you don't require that. This formula also not required. So it is very easy. So you can therefore write down the second one. Then equation 2 becomes like this: integral over c g of this is dx. Dx, how do you write? Dx by dt. That's all. Dx becomes dx by dt dt. Dx by dt can be evaluated. Dt will be kept as such. So what is the conclusion? Function of 2 variable has been converted to function of 1 variable. And similarly, you can write down equation. So this is 2 means 2 is y, right? I'll write 1 here. And equation 2 becomes g of x of t, y of t, dy by dt. So this is the practical way of evaluation. Okay. So using this, let us take an example and then we need some more discussion. Okay. How to evaluate? That's the question. This is how you evaluate. You simply substitute. Substitute means delete the x and put x of t. Delete the y and put y of t. Delete the ds and put that. That's all over. Integrate. There is an interesting point happening here. When I am deleting everything here, this c will not remain c here. Even though I have written c here, in practice what happens is c will also disappear. Then what will come here? You see here, t will come here. Therefore, what happens is, finally what happens is, in practice, c also will be deleted because t is there at the end. You have to say that t is starting from some t1 to ending t2. Starting, it is integral a to b. This is the integration that you are very much familiar. Integral from some number to some number and integrate. So c also converted to limits. That is the advantage. So therefore, here also what happens is, you simply delete this c will disappear and then some limits will come. So let me write down the lower limit as t1 and the upper limit as t. The same thing will happen here also. So now you should understand what we have done till now. There is a complex integration in the plane. We have simplified the integrations in a particular situation where parametric representation is available to you. If it is available, you can do all the integration by this way, where it's a simple limits are there. You know how to substitute the limits, everything. So we'll see as an example. Then when you draw an example problem, then we need some more discussion. Okay. So therefore, here I will write down an example. So the example will contain small diagram. So let me therefore draw this. So you have a 0,